Okay, so let's start. So, welcome everyone. My name is Natan Silnitsky, and I'm a backend infrastructure developer at Wix.com. And this talk is about the key lessons that we have learned over the years at Wix in order to be able to scale our Kafka-based distributed system to more than 1,000 microservices. And I will share with you the best practices, tools, and SDKs that we have created in order to achieve that. And at the beginning, I will start with a very quick Kafka introduction for those of you who are less familiar with it. So what is Kafka? So basically, Kafka is a message broker that has the ability to give us better resilience because we send over messages to it and they are never lost, even if a service gets restarted. And also allows us to have better communication between our services, to have a richer variety of communication styles. For instance, of course, the publish subscribe model. So if we have, let's say, a service with a Kafka producer, it will produce the message to Kafka to a specific topic. And this topic is divided into partitions. So the message will arrive into a specific partition. And you can think about this partition as an append-only log, where the message will be appended at the end of this log, and messages will be deleted according to a configuration. So the default configuration is to delete messages only after 1 week. So it's really not like a message queue. And you can also specify to never delete the messages if you would like. And over on the consumer side, we have these two consumers and they read the messages at their own pace. So they just scan the partition sequentially from left to right. And once they finish processing a message, they will commit it in order to get in order to be able to get to the next message if they are a restart or the partition is taking away from them. So this read action, this consume action is very fast and very performant because usually these partitions will be part of the broker memory. And also, it's not like a message queue. You don't remove the message when you read it. You just continue scanning the partition sequentially. And if you want to scale up, all you have to do is add more partitions and you're able to have more parallel processing with more services. So it's really easy to get to a very, very large scale with Kafka. Okay, so that was a few words about Kafka. Now let's see, how do we use it at Wix? So first, a few numbers on Wix. Wix is a website building platform that allows you to manage your business in the Wix online platform. And we have around 170 million registered users, and 5% of all internet websites run on Wix. We have more than 3,000 people working for us and over 500 billion HTTP requests per day. And we serve around 6 petabytes of static content. Now, with Kafka, we don't serve static content. We just use Kafka mostly for inter-process, inter-service communication. And while the amount of messages produced per day with Kafka is not at Wix scale yet, it has grown very much over the last few years to around 1 billion messages per day. And this early April. And the scaling concern is not only with the amount of messages to handle, it's also with the amount of microservices. So we really have increased the number of microservices at Wix to more than 1,300. And we have now, 2020, more than 300 developers for backend. They write mostly in Scala, but with Kafka, there's also front-end developers that use Kafka in Node.js middleware services. So we have a lot of scaling challenges in multiple dimensions when dealing with Kafka. So we have all these challenges with increased traffic, increased metadata. We have more and more topics and partitions, increasing amount of developers and growing amount of use cases. So large scale. So how do we handle that? So now talk about the lessons that I mentioned. So the first lesson is about dealing with the amount of developers and use cases. And the number one lesson is common infrastructure with common features, because you want to have developers easy onboarding for using Kafka and to have as many common features that all of them have or some of them have already out there, so they don't need to create them themselves. So have better development velocity. Now for this common infrastructure, we've created a wrapper around the Kafka SDK client. So Greyhound wraps both the Kafka producer and the consumer. And the idea is to have an abstraction layer on top of Kafka SDK so that it will be really easy to change things behind the scenes, to upgrade Kafka versions and SDK and APIs, and not bother our developers, and also to greatly simplify things. So the API with Kafka SDK is more boilerplatey, so you can have better, simpler APIs and a lot of additional features that we provide for Wix developers. So we have recently rewrote Greyhound from scratch using the Zio library. So for those of you who don't know, Zio is a functional Scala library that offers composable style of writing code and is optimized for highly concurrent and asynchronous coding style. So that's really good for using Kafka. And while the library is written in Zio, it also offers Scala future-based APIs because, you know, most of Wix's code is still not written in Zio. So let's look at the Greyhound features. The first thing is a simpler consumer API. So here you can see an example of a Kafka consumer, and you need to create consumer with all kinds of properties that you set up with the Kafka SDK, the location of the brokers, and if you want to specify custom serialization, right? So you have a string here for the key of the message and some message type for the value. So you'll need to specify the serializer for that. And then we want to start getting the messages and processing them. So you'll have the poll command, the poll method at the consumer, and then you get the records. And the next time you want to poll, you will do this in Scala style, of course, recursively. And the next step is to have the processing done for each and every consumer record. So we iterate over that. And here we just print the message value field inside the some message object. Very simple in this example. And then we need to decide when to commit the message. Because if you don't commit the message after you handle it, you may end up with multiple processing of the same message. And you can specify auto commit with Kafka SDK, but you'll have less guarantees on the amount of processing that is done per message. So it's usually better to have that control. Okay, so this was the Kafka SDK example. Now let's look at Greyhound. So with Greyhound, you specify a record handler, which you give it a simple lambda for your processing code. And here you can see that we have the Zio environment that we provide the console, the std out for it. And we can also see with the error channel that there is no error possible with this record handler that we specified because there's nothing error. And we are going to serialize the key with string and the value with some message. And on the upmost layer of Wix with Greyhound, We offer Jackson serialization, so you usually don't specify, you'll get the serialization out of the box for your Scala case classes. And then we specify the handler code, and we just have the put strlen for the same message value as part of the type. And instead of creating consumer with all kinds of properties, you just need to specify the handler and the topic and group quite straightforwardly. And you don't need to specify here nowhere when you commit, and the broker's location is injected automatically. So it's much more streamlined, simple API. Cool. So what about parallel consumption? So we have an instance that may have the need to, that may need to consume multiple partitions in the same Kubernetes pod. So when you write stuff with Zio, it's really easy to have parallelization out of the box. Because if you take a look at the Kafka consumer, you can see that basically the polling is done on a single thread. It has to be done on a single thread. So if you want to increase the level of parallelization, then you will need to maybe create multiple Kafka consumer instances, and then that's not really efficient use of resources. Or you need to handle all of the multi-parallelism by yourselves, multi-threaded parallelism. So Greyhound here just uses the Zio fibers. So fibers, for those of you who don't know, are lightweight threads that enable us to work on scheduling context switches on the application level. So the JVM thread is usually not involved in that. So it means much faster performance. And fibers also are very lightweight. They don't take up a lot of resources like JVM threads. So it's very high performance concurrency. And of course, we want to read messages from all the partitions that were assigned to us. So we just push them into the queue for each fiber, and then process them one at a time sequentially for each partition inside each fiber. So it's a very straightforward thing to do with Zio, and you get it out of the box with Greyhound. Cool. Now, sometimes our handler code fails and we have errors. So what do we want to do in that situation with Kafka? We want to have resilient retries. So that can always happen even if our service crashes. So how do we achieve that? Well, with Greyhound, you just define a retry policy, and you specify the intervals and after which you want to retry. So here we have after 1 second and after 10 minutes. And then you only need to do is provide the retry policy for the recurrent handler builder here. And how does it work behind the scenes? So we have an example here of a Greyhound consumer that's consuming from some topic. And then we have some error. So we have a built-in retry producer in each consumer that will produce the message to a retry topic in case of an error. And this message will be forwarded according to the intervals that you sent. So retry 0 will handle the message after 1 second. And if again there's a failure, then retry 1 topic will then have a consumer that consumes it after 10 minutes according to what we defined in the example before. So this pattern was inspired by Uber. You can check out the link here afterwards to get the full blog post on this retry topics design. But there's a problem here, because with the amount of retries you have, if you want more retries, you have more retry topics, and that means that you'll probably need more Kafka brokers. So we have a situation here where the retry topics causes the cluster to grow faster than otherwise. So one way to mitigate this is to, by default, have the retry topics only have one partition, and then you limit this, but still you have a growing size of topics and partitions than otherwise will be without these retry topics. So there are other ways, of course, where you can implement this. All of them have their advantages and disadvantages. I won't go into great details about other alternatives, but this is the design that we chose for Wix. Cool. So if you notice with the retry topics, once you put the message into the retry of 0, let's say, then you can already consume other messages in the original topic, which means you will get messages out of order. So for that, we just have a blocking handler policy that you just, when you use it, it means that the Greyhound consumer will just retry the same message again and again on failure on subsequent intervals. So when you are stuck on the same message over on the consumer side, on the producer side, it keeps producing messages. That means that you have a lag building up between your producer and consumer. So what we've built in this for solving this is for every service, it has an automatic dashboard that will provide you the ability to view the message that is currently blocking. And then you can go over it and decide what to do. You may decide to unblock the message because it's not really interesting, or you have found a bug. In that case, you need to go fix the bug, redeploy your service, and then hopefully the bug is fixed and the message is successfully consumed and the subsequent messages will get consumed and the lag will disappear. Okay, cool. So one last thing for the moment about Greyhound is we have a feature for context propagation that's very important for us at Wix. So you can imagine a use case at Wix where a user, a site visitor, wants to sign up to some site or forum at Wix, a Wix website. So of course, they send an HTTP request over to site members service. And this HTTP request has all kinds of header information in the user requests, like what's the language, geography, also the user type for Wix. Is it a visitor? Is it a registered user? So all of this comes into the site member service HTTP request. Then we produce it to Kafka. The message is produced by the service. And Greyhound will automatically have all this context for the user put in the headers of the message for Kafka brokers. And then we have, let's say, the contact service that handles all of Wix's contacts, and it can consume the message and automatically get all the user context and put everything it needs to put in the database, for instance. And this user context is also very important for us for A/B testing. So we also use this context for experiments. And we get it out of the box serialized by Greyhound. So that also helps with development velocity. Cool. So we talked about the code infrastructure, but what about the other issue with the amount of developers and use cases? They need support. So I'm part of the infrastructure team and I provide the infrastructure code, but also give support for our developers. So we don't want to be a bottleneck. And the third lesson here is to have as much self-service as possible with tooling and documentation. So here we have the example for what happened before we have the appropriate tools that we get inundated for our team. Hey, how can I search for a specific Kafka message? Or how do I increase the number of partitions? I want to increase it for a certain topic. So we didn't want to be the bottleneck. So the idea is to use tools and documentation for them. So what kind of tools are available for Kafka? There is the Kafka CLI that has several scripts that can help in all of this stuff regarding streaming Kafka messages, and changing the configuration. But there are quite a lot of flags that you need to become familiar with. And when you have a production issue, you don't really want to start understanding a lot of stuff. You want to have a quick resolution. So a graphical user interface alternative is the Yahoo Kafka Manager, which is open source. And there's also the Confluent Control Center, which is a paid service. But we've decided to create our own control plane tool in order to be able to help with a customized solution for Wix. So we call this tool the Greyhound admin. And you can see, for instance, the first message screen I want to share is the topics configuration screen. And here, the developer can choose a topic and then see the current configuration in all of the data centers and then change it. So they can change, for instance, the amount of partitions per DC if they require that, and other configurations. Another screen I want to share is the message live stream. So here, the user needs to choose the topic, then they choose the DC, and from which time they want to get the Kafka messages streamed. They can also filter according to some key, and then they press play. Once they do that, they start getting the messages streamed, and they can click on a certain message, and they can see metadata specific for Wix, for which artifact produced the message at which time, and which consumer handled the message. So we can have all kinds of consumers for this specific topic and which time they consumed it. We also want to add here if the handling failed or succeeded. If they scroll down, they can see the message payload. So it's pretty JSON formatting. They can copy parts of the message or the entire message. And if they continue to scroll down, they can see all the headers, the key values headers that are part of this message. And one last screen I want to mention is key value stores. You can have key value stores on top of Kafka, where you have Kafka as a sort of storage. I don't really want to get into it, but it's a very important part of our control plane and Kafka ecosystem at Wix. So we have for in-memory key value store that have really high performance storage. And the users can see all of the values for each key everywhere around the Wix data centers and debug them. Cool. So the other stuff that you need to do in production when you have Kafka as a user, right? People want to investigate what's causing a lag, or they want to add another feature and know how to add retries in case there are errors in production. So in order to have more self-service, we have a detailed GitHub README, and we use an internal Stack Overflow question and answers. And we also have a Slack bot that answers the users automatically from previous answers on Slack or Stack Overflow without actually needing a team member to help them. So here you can see the beginning of our Greyhound README, and over on Stack Overflow, we have one very important Q&A about how to investigate consumer lags. And over on Slack, you can see that a developer has asked some question, and then our Slack bot, ShoeBot, will try and help them out. Hopefully, they can get the answer quickly from the bot. Okay. One last thing about documentation is discoverability. So we have a growing scale and growing amount of metadata, topics and messages, structures. So it's really important for developers to find out these messages, structures, and topics easily. So we have an internal API service that supports that. So our message structure is defined by case classes like we saw before. And we switched over to have the definitions in protobuf in order to be able to consume them by the internal API site. And then the protobuf defines the events, defines the message structure, and you can then discover them on the website. Protobuf was chosen also because we use gRPC services in Wix. So the internal site can show you the HTTP request for the domain and service, the gRPC request, and the Kafka events and message structure. Of course, there are other alternative serializers. You can use Avro, Apache Avro, and you have the Confluence schema registry, which in the same manner allows you to discover the topic message structures and also to get up-to-date versions for the messages. Great. So what about testing? We want to test Kafka, and testing is very important for us at Wix because we don't have QA engineers that actually test our flows. So we usually write it in TDD style. And it's very important that when we use Kafka, the testing have to be easy. So Greyhound offers a test kit that simply injects to the test environment the Kafka brokers and Zookeeper. And then they inject to the test environment also the location of the brokers. So the developer doesn't have to concern with that. And also offers a message sync so that the developer can easily find out if they produce the messages correctly for other services. So this is very convenient, very important for testing velocity and code quality. Great. So let's switch gears and talk about production monitoring. So we have a completely async event-driven style of code, and we have Kafka messages running around multiple services, and it's much more difficult to understand what's going on. It's not like you have a monolith with RPC requests that you can check the stack trace and be done with it. No, it's a much more difficult situation. So it's really important, first thing, to have very good dashboards with graphs and alerts. So Greyhound produces all kinds of custom matrix for our services. And we have the Prometheus matrix service that pulls these matrix, and they're provided to Grafana. And we have automatic dashboards for each of our services that you can see all kinds of matrix in. For instance, what's the longest running consumer handler right now? Because maybe it is getting too long and this indicates there's some problem. Or graphs to show the current lag between consumer and producer. And all kinds of important metrics like the Greyhound exception rate, etc. And of course, you also want to have automatic alerts. So these dashboards also support having automatic alerts on these matrix anomalies and you get the alert automatically to your team's Slack channel and to the team email. So here we can see an example of an alert in Grafana, about slow consumer handler execution. And then the developer can go and check out in the Grafana dashboard exactly what's going on with Kafka right now. And they can go to the other dashboards I mentioned and check out the messages that are currently being streamed. And if there's a message that's currently stuck, and investigate it with all the tools I mentioned before, and hopefully get a quick production resolution. And when you have a bigger amount of traffic and metadata, topics and partitions and brokers, you want to be proactive about broker maintenance. And this is the 6th lesson. You don't want to wait for the brokers to have considerable slowdown because they have too many partitions. There's a great blog post by Apache Kafka about the rule of thumb limit for brokers for the amount of partition, which is best to have up to 4,000 partitions, and each cluster to have up to 200,000 partitions. So the idea is to monitor the situation automatically, and then have as automatically as possible the ability to add brokers when needed, and to split the cluster when needed when you have too many partitions. We're actually right now in the process of splitting up our big clusters to smaller clusters that are more per domain at Wix. And we also monitor the situation with unused topics that can also lighten up the load, because if a topic was only used temporarily, there's no reason we need to keep it around and slow down the Kafka brokers. So delete them when they become unused. So the idea is to be proactive and have the best optimal production environment in order not to get downtimes or very, very slow degraded performance. Okay, now the seventh lesson for today is to avoid active-active ordered produce. So Wix is found on multiple data centers around the world and on many, many points of presence data centers to be close to our users. But still, if you have a situation where you want to, let's say, update the site, and you want the site, this specific site updates to be processed in parallel. So what will happen if you do an active-active design for the DCs? That means that you get the request to DC1 and it's produced to Kafka. And then maybe you'll get to DC2 the next time and it will be produced to Kafka there. And of course, you want each DC to have the entire known view for all the DCs, other DCs as well. So we have replication between the DCs. And what will happen with this replication, is that messages will become out of order in this classic situation. So how can we mitigate that? We want to have consistent processing across all data centers. Well, the simplest way is to have the browser always get to the same DC, to have, for this specific service, a sticky data center, and then the messages will be produced in order into Kafka, and the replication will mean that there'll also be a consistent order also on the second DC. And the consumer on DC2 will be able to consume these messages in exactly the same fashion as consumers on DC1. Of course, the downside here is that you'll need to get to a more remote service, and then it means that you have bigger latency and maybe more errors along the way. But still, this is a preferred solution to actually get eventually consistent views on all data centers. And of course, if you can, try to avoid the need to have this consistency of ordering, because it will greatly help the style and production handling of errors if you have a multi-DC environment. Great. So the next lesson is number 8, and it's about having a lot of traffic on multiple kinds of languages. So we have not only Scala services at Wix, we also have Node.js services, like I mentioned at the beginning. And the lesson here is to avoid using the Kafka SDK directly in Node.js. So we have the Scala and Node.js services side by side. And we have Greyhound for Scala. And for Node.js, we used to have a Node.js specific Kafka library, which produced and consumed. But it's not the same as having the standard JVM library for Kafka. It has more problems. It has less good performance. There's also the question of the single event loop for Node.js, and having the consumer that keeps polling is not really healthy in Node.js, especially when you have high traffic. And there's also the issue where we have Greyhound in Scala with all kinds of features, and the Node.js infrastructure always needed to catch up with the Greyhound set of features. So in order to solve all these problems, we decided to have a Scala service we decided to drop the specific Kafka node library and to have a Scala service, a sidecar in the Kubernetes pod that will handle the produce and consuming for the node app container. So inside the container, we have a service with Greyhound, and it just consumes the messages, for instance, and it will send gRPC requests over to the Node.js service with a new message to process. And this is much more like Node.js is used to, getting requests and processing them efficiently. Of course, there are other alternatives there. Confluent has a REST proxy service that you can use, and other companies also do this quite a lot. It's a very popular solution for having multiple languages supported with Kafka. The issue with sidecars, though, here is that there is bigger memory footprint because we actually double the amount of footprint per pod, per Kubernetes pod, because we work with 2 services instead of 1. But we decided that it's worth it in order to have a simple design and a resilient way to use Greyhound in Node.js. Okay, so we reached our 9th lesson for this talk, and it's about having very special use cases with very high load of traffic. And the idea is to consume and project. So let's see what do I mean. We have our service called MetaSite at Wix that handles all stuff related to the context of the site. So what's the site version of a services asked? Or who is the site owner? Or what kind of apps are installed on this site? And this information is really important for our verticals, Wix stores, Wix bookings, Wix restaurants, and all kinds of other services at Wix are interested, which means that the MetaSite service has a lot of requests. So it used to have a lot of overloading with more than 1 million RPM requests. And of course, it also gives out a big strain on your database for the service. Needs to have high amount of reads and writes for the entire MetaSite objects. So the idea here was to split up the requests and have a special dedicated handling for the context of which apps are installed, because that's really interesting for our vertical services. So the idea to solve it is to first produce to Kafka the entire message update for the site, which includes all the information for anyone who wants to consume it. But then we have the team that's in charge. They have created another service called the reverse lookup writer. And when it consumes this message, it only takes the app's installed context, it filters only that context, and it puts only that information into its own database. So it projects only what it requires for the database, and it has the installed apps contexts that are able to read from the database. And then in order to have better utilization and throughput, they created yet another service that's called the reverse lookup reader, and it splits the reads from the writes. So only this service will have the ability to read from the database, and it will serve the RPC requests that want to understand what's going on with the app's context of the website. So with this splitting of the read and write into 2 services, you can have a much high degree of capacity for reads, have a lot of replicated DC, read-only DC databases, around the globe that offer really high performance reads, and have many, many service instances around the world that are just there for reading. And you have much more read needs than writes in this situation. So the split here really helped with the high throughput. And it was allowed to happen using Kafka with the projection here. We consumed and projected. And the consume and project pattern works really well for the microservices environment, even if you don't have a really huge throughput that you need to handle. It's a best practice to have the databases unbundled and have each microservice in charge of only the part of the data that they are after and are interested. So it's a very powerful pattern that I really recommend you use. And one final note, it also helps in the situation I described earlier with the split of with the writes on from cross DCs, right? It also helps in that situation. Okay, we've come to the last lesson for today, and it's about, is Kafka messaging is event-driven, right? So is it only relevant to service communication? When you have browser to server interaction and the user is waiting for a reply, is Kafka, can Kafka help there? Probably not, right? Well, wrong. Actually, if you use WebSockets, then WebSockets and Kafka can work really well together. And they offer a completely distributed and event-driven solution. So here you can see an example with a process of importing contacts into Wix platform. And it involves all kinds of microservices. And they interact using Kafka. So if we want to have a request coming from the browser, the first thing it will do, it will subscribe for notifications from the WebSocket service. Then it will actually send the HTTP request to import the contacts from the CSV, let's say. Then we have the contacts job service that creates these import jobs. It will produce the job over to Kafka. Then we have downstream services that actually handle all kinds of imports. And then once they finish the import job handling, they can notify the WebSockets that the import job is finished. And then the WebSocket service can notify the user waiting in the browser. And they can also have notifications from the services in intermediate stages of the process and keep notifying the user as the process is evolving. So the user is really unaware of the fact that the request was handled by multiple services using Kafka messages produced and consumed all over, because they get all the notifications they need from the WebSocket service. So it's completely async, event-driven process from end to end. So to summarize, what do you do when the traffic and metadata, amount of developers and use cases keep growing, the scale of all of these dimensions keep growing? Well, Wix has created an entire ecosystem to support large-scale Kafka-related needs in order to be able to support all the dimensions that I've mentioned. And we want to start contributing all parts of this ecosystem to the open source community. And I'm glad to report that Greyhound is currently open in alpha, so you can check out the link over here. And soon it will be more stable, and I really recommend when it moves over to beta and it will be part of Maven Central, that you'll be able to use it. And we hope to open source also the other tools I mentioned for the enjoyment of the open source community, like it helped us at Wix. So thank you very much. And I will probably be able to answer the questions on Slack. And also, if you want to stay, I'll answer them on the Zoom group chat. You can get updates on all kinds of Kafka information from what we know of at Wix, updates on our open source efforts, and also about our Zio writing, with write code in Zio in our team. You can get all that information in Medium and Twitter, and also the slides I share on slideshare.net. So thank you very much.
Nathan, you posted to your Slack channel a great list of topics to discuss. Really great. It would be wonderful if you could follow it. Might be Kafka plus WebSockets is mind-blowing. Could you tell about it?
Kafka and WebSockets, sure. Let me switch to what I wrote there. So let me close this. Right, so like I mentioned in my talk, if you really want to have an end-to-end event-driven asynchronous experience in your system from the browser all the way to the backend services pipeline, then using both WebSockets and Kafka is a great way to achieve that, where you can keep updating what's going on inside the browser with the WebSockets notifications during the entire process, no matter which microservices currently involved. So the Microsoft communication is done in Kafka, and the notifications back to the browser is done with WebSockets. So one interesting use case that I've implemented together with my team is we have our Kafka and Greyhound. Greyhound is the library we wrote on top of Kafka client. So for Kafka and Greyhound, we have our own control plane. We call it Greyhound admin. And the idea is to have production monitoring and debugging. And we are spread out, and the whole operation is spread out across multiple data centers, right? And it's really difficult to start gathering and interacting with different Kafka clusters on multiple data centers at once, because you want to collect all the information on topic configuration for all data centers at once and see it in one screen. Or you want to easily switch from data center to data center and start streaming, or start streaming messages and fetching and seeing topic partition lags. So we use the WebSockets for that. We use WebSockets and Kafka replication between clusters in order to achieve that. So our primary microservice that handles the traffic from the browser is found in one data center, but then it's really easy to get the information from all data centers by first getting the information to Kafka. So we have a command, and this command is put into a Kafka message. Then all of the data centers consume this message and say, okay, was this command for my data center or not? If it was also relevant for my data center, then I'll continue processing it, or I'll just discard the message. And then in my data center, I process the message, and it doesn't matter. And then I have different microservices for different screens in the control plane, right? So I can continue publishing in Kafka. And once I gather all the information I need, all I have to do is notify with the information I have retrieved through the WebSockets back to the browser. Because one part of the command is the channel ID that the browser is subscribing on, and the specific events that they want to get back. So it's a really nice flow for having end-to-end, completely event-driven style using both Kafka and WebSockets.
Do you use some kind of special API gateway, or it's self-made, or RPG, or whatever?
Right, so specifically in the control plane, we do not require an API gateway, but in general at Wix, we have a lot of cross-cutting concerns and the whole issue of discovery, so of services. So yeah, we use Envoy for our cross service communication, and we have an API gateway that currently fetches caches and fetches information regarding the basic domain objects of Wix, for instance, getting the site information and getting authorization and all the permission and the user identity and all that stuff. We get it through an API gateway. And we also want to introduce through Envoy the idea that already Envoy will have all the information needed. So we won't even need to go through a specific gRPC call or something like that. But it's out of the scope for Kafka. So I hope I answered your question.
Yes, you answered the question. Quite interesting use case with Envoy. Thank you. Thank you. So command to Kafka. It's clear. Thank you very much. Nice.
Okay. Thank you for your question.
My question is, I have, actually, it's not really a question, it's a reaction. I have worked a bit with Kafka in my own work. And what I found interesting in your presentation is the fact that Kafka can be used as a database. Meaning if you don't limit the time data remains in Kafka, by default is 1 week, I think. But if you remove this constraint, then you just have a database. And the project I was working on before the COVID was a project which was basically a streaming application, but they were using a normal database, a PostgreSQL database. So thanks to your presentation, I will be able to tell them to just exchange with Kafka.
So thank you, Rafael, for your comment. I do have a few caveats on that. So yeah, you can use Kafka as a database, but it's not that simple. I'll tell you about the use case at Wix and what Confluent, the company that is maintaining Kafka, has as a product. So at Wix, we use this as in-memory key value store, meaning that it's right that the topic persistency is forever. Messages of certain key updated with an updated value will never be deleted on a compacted topic. But the idea is to have very fast processing for reading and writing the key values. So we only allow it for small data sets that can fit into memory. So we don't recommend it for our developers to use for very large data sets. But it's for like configurations that you have in your application and stuff like that. It's very, very convenient, and it's very flexible. You spin up your instances, restart them. You load up to memory. You tell your health test that you're ready to start getting HTTP requests or gRPC requests, and you're ready to go. Now, Confluent has a different way of looking at this. They use RocksDB. So RocksDB is a sort of, I think it's a file-based database that can house a lot more, has a lot more data than in memory. Okay, so they load the Kafka topic into a RocksDB, and their design for, in that case, is they have several instances, application service instances that just load the RocksDB and allow to fetch from it. And you have other instances in your architecture that do the Kafka streams and the topic pipeline processing And if they need to, they can access the information found in RocksDB. So you have like a separate, you have an architecture that is like split between the services that contain this information and the services that do processing. So it's a very, very opinionated architecture, and it's a bit less flexible, but it's understandable because you want to load all the information to RocksDB first. But if you do that for every instance that you spin up, it will take too much time to get the RocksDB initialized from scratch, right? So it's a more persistent situation with RocksDB. So it's two kinds of style, and you really need to see what can what kind of style is right for your architecture and your needs.
Okay, thanks.
Thank you, Rafael, for your comment.
Natan, complementing previous question, could you share your experience with compacted topics in a scale?
Right. So like I said, with compacted topics, that means that information is always up to date for every key with Kafka. So like I said, we load it up into memory in our use case. There is a situation where you first need to make sure that you loaded everything up into memory before you start getting requests. So that can be a little bit tricky. So the more information you store, it means that your startup time until the application instance, the pod is ready, will be longer. And you usually you won't want to get requests during that time because your information is still getting updated and it's not yet, it could be stale. So that's something to consider, using compacted topics and loading them into memory. But other than that, our developers are really pleased with the performance of it when they read and write from it in memory. We also have a feature when we try to do atomic updates for these compacted topics, meaning that we have like a transaction topic that it is in charge of doing the updates, and we are able to read information and update it in an atomic fashion. I won't get into too many details, but we also have this approach, and of course it means that there are other challenges like read after write, challenges like that when you do atomic operations. You want to stay consistent. I mean, if you split the read and write, then it's no problem to have eventual consistency. But if you want to read what you wrote, then it becomes more tricky. But it's with Kafka, usually you solve it by making sure that you finish with some offset before you continue, stuff like that. You have like bookkeeping on the offsets. And actually, recently for larger data sets, we've decided to work with DynamoDB, AWS DynamoDB, because it offers both high performance and much larger scale. So we're currently in early stages, but it looks very promising.
Thank you.
Thank you for your question.
You know, that's not a question. I just following list you Natan posted, and all the topics are interesting. For instance, about Greyhound and sidecar design.
Yeah.
Why per pod? Why not per node?
Right. So, well, it's a good question. So we thought about it quite a lot. So the idea with the sidecar is that we proxy the producing and the consuming from the Node.js instance to our Scala service. And with actually having this in pod, meaning that it was very simple to design it and implement it, because the life cycle of the consumer is really easy to handle. The pod life cycle is completely related to the node application life cycle. So if the node app starts, the sidecar starts, and if it shut down, then the sidecar will shut down. So it's much easier to handle the consumer life cycle. It's not almost like it's a regular Scala service that consumes. If you put it in the node in a daemon set, it means that you will need to start having introduced a lot of logic for handling the consumer life cycles, handling the partition revocations and all of the reassignment. So you're basically doing a mini Kafka broker inside each node, because you have a lot of logic to make sure that the entire system basically is up to date in a much more, you have a much more stateful environment, which means it's much more error prone and much more complex design. The trade-off here, of course, is that you're utilizing more memory and more CPU because you're found in each pod, unlike if you were inside the daemon set node. But that's the trade-off, and we decided to go with simpler design. And we're trying to reduce the memory footprint. I played around with the heap allocation for the JVM and played around with the amount of buffering of messages we do with when we consume from Kafka. But that's the current situation.
Not bad. Not related exactly to Scala, but which kind of network layer do you use and how you handle latency, or it's not a problem?
You mean between data centers and requests?
No. Network layer inside pods and KHS. Network CNI, how to name it?
Again, a network inside?
Those part of Kubernetes which handles communications between nodes, between pods, etc., etc., etc. Network layer of Kubernetes.
Ah, I see. Well, what I'm not that familiar with it. What I know is that for our gRPC communication between pods, we use Envoy, but I'm not really familiar with the technical aspect of the networking between the pods.
Okay. Thank you. About Envoy. Envoy is okay, yes? It's production grade, everything is fine with it.
Yeah, we use it. We're very pleased. You know, sometimes there are, no, I think it's much more mature now. I mean, at the beginning we had a little bit more, you know, growing pains, but I think it works really well. Yeah. We have our own Istio. We wrote our own Istio.
Whoa.
Well, we had to because we migrated from our chef design and zookeeper and all of that. Yeah. We didn't start from scratch. If we would have started from a clean slate, we probably worked with Istio.
But it's one more service mesh.
Well, yes, but it's because of our previous system constraint.
Legacy, yeah, understood. Thank you.
We have many overlapping usage of Kafka and Akka. And the questions is Kafka coming after Akka, or they coexist in some senses? When you recommend one and when the second?
Right. So the question is when to use Akka, when to use Kafka? Did I understand?
Yes, and are we have still use cases for Akka or not?
Again, sorry, I can't hear you well.
I still exist use cases for Akka, which Akka is best suited for a set of tasks, or it is better to prefer Kafka against Akka in all environments.
I see. Well, I specifically have never used Akka. I used other actor-based system, never used Akka itself, but I know that they have quite similar ways of handling distributed work, right? And having it's also like event-driven style, I would say, with both systems. But because I'm less familiar with all of the nuances of Akka, I know that there are tons of services out there that use Akka and they are very pleased with it. And so, you know, I mean, I know that a lot of, I know the differences between Kafka and message queues. That's quite a straightforward way to look at it. So I guess with each actor, you also have a queue, right, that you pull stuff out of. So maybe this is the big difference where you can have multiple consumers that I mean, actually it's quite the same, but I'm sorry, I really don't have that a lot of experience with Akka, so I can't really answer that question. I'm sorry.
Thanks. And can I ask you about your tech stack?
Sure. So so my tech stack is, for the backend we use Scala and Zio for the last let's say a few months already, maybe half a year. We started with a lot of interrupt that we needed to do. We rewrote Greyhound to offer us Zio API and stuff like that. So it's coming along nicely. I also have front-end work and do that with React and TypeScript. I don't understand why people still use JavaScript and not TypeScript. And also, of course, a Node with TypeScript also. But I really do enjoy working with Zio. It offers such a rich API and also ecosystem. The composability, the compiler errors that really let you understand how to write the code in a more correct fashion. So it's really fun to work with Zio.
Thanks.
I really like the advances that they made in the type system of TypeScript. So they offer union types and they have conditional types and type aliasing, all of that. So I really like that they introduced that to one of the biggest tech stacks in the world. But I do hope they manage to reduce the boilerplate even further, you know, because with Scala, everything is much more succinct and elegant. So I hope they advance in that direction.
And are you trying to play with Scala 3 in large Scala?
I'm really excited about the promise of Scala 3. Like with enum, so I mean, Scala enumeration was terrible, for instance. But, so enum is a much simpler ADT than like trait and case objects and case classes. That's great. Union types will also dramatically improve our lives when we write with function style Zio, the Zio environment, and won't need the cake pattern probably. Much less cake pattern use, and all of this simplified work with implicits, because a lot of people are afraid working with Scala because it's so powerful, and then everyone does what they want, and you get implicits all around, and you're not sure where they came from. So it'll be much more opinionated, no more implicit conversions like everywhere, and you have like, you want to do an extension, you do extension. It's more comprehensible. So I'm really excited for the future with Scala 3. Thank you all for coming and for the Q&A session. I enjoyed it. And Thank you.
Thank you very much. Have a nice day. Bye.
You too. Have a nice day. Bye-bye.